Yeah, hello, this is NixOS Discovery, and I'm just gonna start to record because it's really a lot. It's really a lot. What's a lot? No, I was thinking simply to start the NixDev tutorial on the modules because it just seems like such a deep subject, working with local files, NixOS, virtual machines, the module system. All right. Much of the power in Nix packages and NixOS comes from the module system. Now, I'm not sure if I'm going to really do the tutorial now, but I'm just going to start this thing on because there are two in Finicilded, the Nix Hour 54 and 55 on writing NixOS modules. I was looking at the 54 and I wrote some things down that I like to share. Then I watched the Robert Hensing Fixed Points All the Way Down. This is the Nix Developers Dialogues 2023 with Frickler Handwerk. That's kind of it's more like an interview kind of a thing. And then at one point, Robert goes and they share a screen and he shows we should check that actually. Yeah, he shows the portable service layer. So at one point, Frickler Handwerk says what do you recommend? Like, how should one start? How should one start with, NixOS modules? What should one do? And Robert says that rendered. Is it this? Robert says that one should play with a portable service layer or write a module, right? So, but what does that mean, right? I mean, as far as I understand, let's say you have a program. So that's the whole point, I guess, of it's like NixOS modules are the Nix packages for a Linux distribution. Well, that makes no sense, right? But just as you have Nix packages that kind of package a program that you download and it works in your NixOS. The NixOS module is like you turn some kind of functionality or a program into a module that you can then plug into your NixOS. But the upside is that the program itself as a module has all of its options and configuration that you would otherwise have to type in that you would otherwise have to set by hand after installing the program. You can somehow the module enables you to declare everything, all the options and configurations of the program itself. So it basically turns it into a little NixOS. It's just as you have the configuration.nix, a file that you declare your system, everything how it's going to be defined. So like if I go, you know what? I have a home manager and sudo x. So yeah, here we have home manager, right? So at first I remember I was really confused because you have these are imports, right? And basically imports is one of the options of the modules. So this whole file is basically like a module. So you see it has here and imports. Imports is one of the things that a module can do, like you import other submodules, I guess. Now the question is, when we write this, yeah, like, is this a submodule or is this a submodule? Why is this here written? These kind of brackets, right? Imports. Yeah, like in configuration.nix, there is imports. Now, why is hardware configuration.nix imported with this, and home manager NixOS and home manager NixOS is imported with these guys. So different ways of importing files. All right. Files or modules are used based on the context and location of those files. Here's an explanation of why hardware-configuration.nix is important with /, and home manager NixOS is important with the, I don't know how you call these brackets, squarely brackets? No, it's not. It's pointy brackets. Hardware-configuration.nix is typically imported in your configuration.nix like this. Yeah, okay, we get that. Angle brackets, thank you. Angle brackets indicate that the path is being looked up in the Nix expression search path. That's correct, yeah. Oh, in the Nix expression search path. This is not a relative or absolute path, but a reference to a package or module available in the Nix packages or other channels included in your Nix environment. Oh, exactly. So if you would import, let's say you import your module through a channel, then you would do this. I know because NixOS has this like the Musnix or something like that, like all the audio programs are available also through a channel. And the way you import it in your configuration.nix is with imports and this. So how do you check, like, and because you've added the home manager as a channel, right? And you import it here with the angle brackets in the Nix expression search path. Okay, that's great. So it goes, the Nix search path means that Nix will search for the home manager package in the channels specified. And within that package, it will look for the NixOS module. Package provided module, yeah. Summary. Where do I check the Nix? Like where do I see the Nix search path? Like, where do I see it? I think you can find it. I know you can. There is some kind of echo Nix path. Really? Echo Nix path. Nix path. So what do I have? Nix packages, Nix var, Nix profiles per user, root channels, NixOS. Colon NixOS config, NixOS configuration.nix, Nix var, Nix profiles per user, root channels. But what does this mean? You know, like, what does this mean? What does this mean? Understanding and modifying Nix path. Adding custom paths. If you want to add a custom path to the Nix path, you can do so by modifying your shell configuration. Export Nix path to my custom Nix modules. Oh, but why would I do that? Why would I modify the Nix path? Isn't there, like, using Nix shell with custom paths? You can also temporarily modify the Nix path for a single session. Default channels, channels list. Yes, the channels are included in the Nix path. But why would I modify? To see which paths Nix is searching, you can use Nix instantiate command with the find file option. For example, Nix instantiate find file Nix packages. Find file Nix packages. Nix var Nix profiles per user root channels NixOS. Does it find like stuff like bash? File bash was not found in the Nix search path. Why would I modify the Nix search path? List channels, home manager. Oh, home manager, yeah. So that's all what we have. Nix var per user root. What's per user? It's why would I modify it? Like modified it. Why would I modify? Can be useful. Using custom or local repositories. All right, yeah. Private repositories, overriding defaults, testing changes, organizing configuration. If you have a complex NixOS configuration split across multiple files and directories, you can add these directories to the Nix path to simplify references and imports in your configuration.nix. Centralizing custom modules. Oh, that's cool. If you have custom NixOS modules or home manager configurations that are shared, you can centralize these in the directory and include that directory in the Nix path. In this way, all machines or users can easily access and use these shared modules. Oh, these are like more advanced things. I mean, this makes sense. I can get this, you know. Why would you? Developing a custom module. My custom module. Yeah. So let's get back to this. This summary. So portable service layer. Is this start date? Author Sander van der Burg. Sander van der Burg. Summary. Oh, this is nice. There's a summary. Yeah, this I should study this. There's so much to study at this, but in some sense, I mean, look at this. If you go to NixOS modules, right? The part in the NixOS manual. So I guess here it's kind of structure module syntax. So NixOS has a modular system for declarative configuration. Right. Oh, wait a second. Let's get back to this. So what did Robert say? So yeah. So I just wrote here some points which are kind of cool. So Frikla says, you know, like, what is the module system anyway, and where does it come from? So he says it does originate from NixOS, but it's kind of its own component in a way. So when you write configuration.nix, the NixOS config file, it's a module in Nix language. So configuration.nix is a module itself, all right? That's a module. You know, it's sometimes you would think like that's the configuration and then you import some kind of a module, but it's basically, maybe that's why it's called fixed points all the way down, because it's modules. Like the whole thing is a module. I guess it comes from functional programming, like everything is a function, right? Wait, it's a function. No, it's not. Wait. Configuration.nix, the NixOS config file, it's a module in Nix language. Wait, he says wait. So guess I was wrong. Wait, it's a function in the Nix language, I meant to say. Am I recording? I am. And that's because it's a module. So a module. Basically, it's a function that takes as its input the configuration as its return value, and generally this attribute set, right, with a whole bunch of stuff in it, and that's like the part of the configuration that it contributes. So it's a function that takes as input the configuration. And the return value returns the part of the configuration that it contributes. Wait, if you say it's part of the configuration, how is it supposed to take the configuration itself? Just a moment. Okay, so a module basically, yeah. Wait, if you say it's part of the configuration, how is it supposed to take the configuration itself? Yeah, that's like magic, right? Nix is a lazy language, and that means that you can pull off some tricks with recursion. It's called explicit recursion, where you have the ability to pass the return value of a function back to the function itself. Like the simplest function that does this is called fix, and like recently we documented that one with the documentation team as well, because it's like a very alien concept if you are used to like normal, strict, non-lazy programming languages. But yeah, that's the thing you can do. The module system addition to this concept is that it actually takes care of all the merging and some other aspects of the configuration system, like documentation and stuff like imports. You can include some other files within as well. All those things taken together make up the module system. But like the simplest function that does this is called fix. What's fix? Explicit recursion, where you have the ability I think that's like the simplest. Show me the simplest program in Nix language that can be anything, like finding a common number between two lists that does this. Yeah, I write actually terrible, but I like with ChatGPT that it knows what I mean. Sure, let's create a simple program in the Nix language. Stop scrolling. Sorry, I mean this scrolling thing is like all the artificial intelligence and everything. Let's just fix the scrolling thing. Sure, let's create a simple program in the Nix language that demonstrates explicit recursion. We'll write a function to find a common number between two lists. The function will use explicit recursion by calling itself with a reduced version of one of the lists. Yeah, that's recursion. That's what I know from Haskell. Yeah, like find common, and you have list 1 and list 2, right? So let's like wait, console. No, I already have it. What's going on here? This is a really weird time with GNOME. cd dev. Let's do find common Nix and what? Let define the recursive function. Okay, right. That's let find common. Find common is what? Find common. Okay, from what? From list 1 and from list 2. That's kind of, no, this is not good. We have to put a colon and list 2. Okay, so we have two lists. The reason being, can we do like undefined? No, we can't. So expecting, okay. wait, I could do like and find common. Will it work like this? And some expression. Wait, and call the function. Find common list A and list B. Yeah, find common in list 1 and list 1 and list 2. Will it work like this? Undefined name. Find common undefined. Does Nix have undefined? No. Okay. Anyway. So find common, list 1 and list 2. Okay, so let's find the common number between two lists. So, okay. Now we're going to do, if list 1 is what? Equal to, okay, if list 1 is empty, right? Then null. That makes sense though. So if list 1 is empty, then null. But why not if list 2 is empty, then null? Else if list 1 is empty, then null. If list 2 is empty, then null. Else if, let's do what's gonna happen. Else if what? Lib element, so element of built-in's head list 2, then built-in's head list. Okay, yeah, this looks more confusing than with Haskell. This is more confusing than with Haskell. Yeah, I think this is one of the reasons like some people I guess don't like Nix. No, I'm not gonna start into that. Let's just talk about how I experience things. So this is a lot of words. It should be simpler than this. Like, can I use like an X or Y? No, I cannot. Else if so the point being is if the head of the first list, yeah, it says built-in's head of the list 1. So if the built-in's head, if the head of the first list is same, so if the head of the first list, is an element, I guess this means that if it's the same when comparing it with the list 2, then built-in's head list 1, then built-in's head list 1. Gosh, this is so terrible with Helix. How am I going to write? Why they don't fix this? It's unfortunate. Let me try. I like Helix and Vim find common. Let's do the find common. Let find common what? List 1 and list 2. Find common list 1, list 2. If list 1 is what? Equal, if it's equal to an empty list, to empty, then null. Else if lib element built-in's head of a list 1, list 2, then built-in's head list 1, then built-in's head list 1. Else if again, and now yeah, else find common. Else find common built-in's tail of list 1. Yeah, else like if the head of the first list is not the same, you compare the head of the first list with the second list, and if it's not a common, then you find the common from the tail of the first list with the second list. But how does it work? You know what I mean? So if the head is the same, if the head of the first list, so this is the head, right? This is the head of the first list, and this is the tail of the first list. So if the head is same as some element here, a lib element, I guess lib element checks the entire list, it's possible, then, you know, then built-in's head list 1, then give me this number as the common number. Otherwise, find the common number between the tail and the second list. So then it does the same. This is the recursive call. And then it does like, oh, is it 2? No, it's not. No, it's not. Then don't give me the head. Then do it again. Find common of this tail, because then this turns into the head. It's like, yeah, call the function with the example lists. List 1, else find common list 1, list 2. Find common. Yeah, I'm not sure. I forgot how do you load this? NixRepl. So confusing. You have to type like NixRepl without the dash, and then there is a dash here. How do I find running Nix instantiate eval? Oh, we didn't do it. This is not over. So list A is what? 1, 2, 3, 4, 5. And list B is 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Right. Now we're gonna define in. Call the function with the example lists. Find common, list A, and list B. So that's our complete program. And now we do Nix instantiate. Explanation. Find common, list 1, list 2. This defines a function find common that takes two lists, list 1 and list 2. Okay, that's clear. If list 1 is the same as an empty list, then null. Okay, yeah, that's the base case. We always have a base case for recursion. So if list 1 is empty, return null, indicating no common element found. Else if, so the second choice, right? Else if lib element built-in's head list 1, list 2, then built-in's head list 1. So okay, what this basically check if the first element of list 1 using built-in's head list 1. That's what this means. Yeah, check if the head of the first list is in list 2 using lib element. Ah, exactly. So the lib element checks the entire list too. If true, return this element. So it's slightly different than comparing the first, yeah, this is slightly different than the example I did in Haskell. Yeah, not sure now. Because this one checks the entire list too. So check if, okay, here it's like, get me the head, get me the first, let's call it the first. Get me the first of the list 1, and you get some kind of a number. And now with list lib lm, like check if this, you know, like check if this first is also part of the list 2. right? Check it. If true, then return me this, because that means that's our common number. But why is this explicit running the program? So, you know, like what's then the difference between explicit and implicit, I guess, recursion? In the context of programming in functional languages like Nix, recursion is a fundamental concept. Wait, where a function calls itself to solve smaller instances of the same problem. That's clear. The distinction between explicit and implicit recursion lies in how the recursive calls are made. Explicit recursion is when a function directly calls itself within its body. The programmer explicitly writes the recursive call in the function definition. This is the most straightforward form of recursion. Okay, that's like the most common example. Example in Nix, finding a common number. That's what we just did, right? Find common. Wait, should we at least run it? Nix instantiate. Let's prove that it works. Eval find common Nix. No! Do I have an undefined variable lib? Oh. I have a lib here. It's not a built-ins. Yeah, you see this? It won't work. It won't work because lib is in Nix packages. I have to import lib. Maybe if it's work. So this is what happens, right? And this is, let's see what chat will write now. We have to somehow declare the lib. Yeah, we have to declare the lib. Here's the corrected Nix program that includes the lib definition. Let packages import Nix packages lib packages.lib and then define the recursive. All right, let's try this actually. So it will not be like, you know, like this, you know, lib. I thought it will be this, but it's not. So it will be import the Nix packages library. Packages, import. I see here we have again angle brackets, and this is like just an empty option. And then we do lib packages.lib. I think this should work, right? It looks like it will work. And it does work. Kind of slow, it took a second. Why did it take a second? Nix instantiate, let's try it again. Look at this. Very slow. So it found 5, right? And 5 is the common number. I look, but 5 here is the end of the list, here is at the beginning of the list. Find common. Yeah. Lib element. Okay. I guess you could like here I see you used lib lm to check the entire list, but can we like make a recursive call to compare the head with the head of the list 2, and then if the first of the list 1 is smaller than the first of the second, then can we like discard the first of the list one and move on to the rest of the rest of the list one, and then do the same comparison, kind of like x equals y is null. No, x equals y is x, right? But if x is smaller than y, then yeah, but that works like if x smaller than y, then you would do x's compare with y's and such. Sure, we can create a more specific recursive function that compares the heads of both lists and decides how to proceed based on their values. This is a different function. Yeah, here's how we can implement this logic in Nix. Oh, define the recursive function to find a common number between two sorted lists. Find common. Okay, let's try this. So this is our first. So vim find common 2. Let's common prim. Let's common prim next. Can I do this? No, I cannot do this. Wow. Why can I not do this? Oh, no. Common 1. Okay, common 1 next. No, this is common 1 next. Common head next. Find common head. Just 1. Let define the recursive function to find a common number between two sorted lists. Find common list. Oh, right. Find common is list 1, and list 2, right? And now if list 1 is what? Is same as an empty. This one was missing. Yeah, what about the list 2? And so we are using and, the Boolean operator and list 2 is same as is empty, then no. But does that mean, shouldn't it be or? No, this, yes, shouldn't it be or? This is or. It's not and. And would be the what? This sign, yeah. Okay, else, LCO. Else what? Let what? X is what? Built-in's head. Oh, that's the X, yeah. Built-in's head of list 1. And Y will be built-in's head of list 2. That makes sense. And in what? Okay, if X is same as Y, then X, exactly. So if built-in's head, if head of the first list, so let's say you have 2 rows of numbers, right? The first row or list is 1, 2, 3, 4, 5. And the second list is 1, 2, 3, 4, 5. So if X is same as Y, then X. Of course, in the list, what we got was like 5 was the common number and 5 was the last number in the first list. So then this would just not give, this would fail, this predicate. So if this, then X, else if, then if it fails, then we go to the second predicate. Else if X smaller than Y, then find. So if X is smaller than Y, we should discard the X. Why? Because it's smaller than Y. Maybe this kind of presumes that the lists, I'm not sure if this presumes that the elements of the list are sorted. Because if X is smaller than Y, then find me, or no, no, I guess it just takes a long time if it's not sorted. If X is smaller than Y, then find me the common of the rest of the list with the first list, with the second list, right? So if the first of the list 1 is smaller than list 2, than the first of the list 2, then let's move out the first of the list 1 and let's check the rest of the list. So come on, the rest. Let's see now the head of the rest of the first list. If it's same, no, it's not. Maybe if it's smaller, oh, then discard it. Then bring me the rest. Probably it will be written if it's bigger than y, then you would do the other way around. Okay, let's move the first of the second list. Remove it, bring me the rest of the second list, and let's compare now. So if x is smaller than y, then find common in what? In built-in's tail of the list 1, right? Find common built-in's tail of the list 1 and list 2. And list 2, I was not sure how do you write this. And list 2. Else, and even in this is not true, then find common list 1, exactly, of list 1 and built-in's tail of the list 2. Exactly. Yeah. So example, sorted lists. Sorted lists. So list A, 1, 2, 3, 4, 5. And list B is 5, 6, 7, 8, 9. So in call, now we're going to call the function with the example list. Find common list A and list B. So this will work now. Next, instantiate eval find common 1 dot nix, and it's 5, right? I guess we wouldn't need this. Like maybe we can just let's try this. Yeah, if I write and find common list A, list B, list 1, list 2. I guess I can leave it like this, list 1 and list 2. Maybe this will work because I just want to have, now maybe I can put in an arbitrary list. Let's try again. Undefined variable list 1. I cannot. List 1 and find common list 1 and list 2. Yeah, but I'm not sure, like, what if I want to input arbitrary lists and not calculate list A and list B? To accept arbitrary lists as inputs, find common. Define a function to sort lists. Example lists. No, I want to be able to call. My cat is always eating some plastic. No, I want to be able to call find common and then 1, 2, 3, 4, 5. And 2, 3, 4, 5, 6. I want to input the lists themselves. You want to be able to call find common without your lists directly as arguments. Yes. We'll adjust the code so you can pass the list directly to the function call. I don't want to sort it. Find common, sort. Find common. Oh, I guess it will only work in the definition. Yeah, not sure. Okay, I don't want to. This is something find common. Okay, but I guess it makes sense. This is explicit, and what's implicit? Oh, again, what's implicit? Recursion. Implicit recursion refers to situations where recursion is handled by higher order functions or language constructs, rather than by explicitly writing the recursive calls yourself. The recursion is hidden inside the implementation of these higher order functions which manage the recursive process for you. Applies a function to each element in a list recursively. Oh, well, map is such a function. You don't have to, you don't have to explicitly, like you just say map, and map does the recursion implicitly for you. Filter is the same. Fold R and fold L. Yeah. Okay. How long have I been recording this? 46 minutes. Yeah, this deep dive probably is going to be long. I'm not sure, but it's interesting. Okay, like the simplest function that does this is called fix. What's fix? And like recently we documented that one with the documentation team as well, because it's like a very alien concept. Well, it's not so alien, I guess. Maybe it is, yes. If you are used to like normal, strict, non-lazy programming languages. I'm not used to those, yes. But yeah, that's the thing you can do. The module system addition to this concept is that it actually takes care of all the merging. What's the fix? Simplest function, fix. I don't know, simplest, maybe we'll find like this, function fix, NixOS module system documentation. Who will ever find fix? Because probably we'll find fix this, fix that, using a document outside NixOS. Issues. NixOS Home Manager, Nix Darwin used the NixOS module system. As it can be used outside NixOS, I'll refer to it as the module system, instantiating eval modules. Creating your own module system evaluation begins as a simple task. All you need is lib eval modules and supply to your module list. Documenting your own module system. Last month I created Wrapper Manager. So I've heard about this user that has a snake, Viper ML, postmodern configuration management. What's this? A white circle? Okay, postmodern. Packages. Build a custom new shell wrapper that self-bundles its configuration and dependencies. Config new shell is not needed. Wrappers new shell. So this is an attribute set with a, so this would be like a sub-module. Base package, packages new shell flags, starship, result, new shell executable, module documentation, installation usage. Flake. level. Let's get back to this. The module system addition to this concept. Okay, very briefly on this technical detail, what's this merging about? In a configuration like that, generally you don't think of it as being modular because often a configuration is it's this file that gets passed to a program and stuff happens in the way that's specified in the file. But when you're dealing with something on the scale of an operating system, you have like a ton of configuration that goes into a ton of programs, and that sort of all builds up, and you can start making abstractions that make it easier to use those things together. And so in such a context, configuration system isn't just like a little config file parser anymore. It starts to become its own thing, and that's why you have like configuration languages with a bunch of actually general purpose programming capabilities. That's what Nix provides. It's basically a library for Nix that provides a bit more high-level concepts than Nix itself doesn't know. So one of them being merging in the other? Yeah, so merging. And like the whole syntax for these modules is you can write them as a function, but if you don't have any logic or any fancy stuff going on, you can just pass an attribute set instead. Yeah, so there's a little bit of complexity there that is mostly complexity on the side of the module system. It just makes it easier to use. So can one imagine module system being a language within a language? Yes, that's absolutely correct. You could call it embedded domain specific language. Although it's not that domain specific unless you call general configuration a domain, which maybe it is. Oh yeah, Sylvan has done some work on it as well around the time of RFC42, which is settings, where you can have these attribute sets. It's basically a dictionary that can contain arbitrary configuration, which is then translated to formats like YAML, JSON, and whatever in like generic manner. That wasn't a thing before that time, so that's something Sylvan wrote, and that's also the time I got involved with the module system because I noticed he was contributing and he didn't get any reviews. RFC42. What's the NixOS RFC42? Config option has been accepted. When was this? 2019. Author Sylvan. Oh, that was a long time ago. Structural settings instead of stringly extra config. I remember this extra config. In some of the settings. That's kind of nice. So NixOS modules often use stringly typed options like extra config to allow specifying extra settings in addition to the default ones. Yeah, I guess this is like they had you define the default ones, and there are all these little more configurations that you just don't know how to put them, so you put them in extra config, which is basically like being lazy, right? And you just have all this room. It's like you have this room where you just put the rest there. I have my own room, nice and tidy, but this room is filled with a mess. This has multiple disadvantages. The defaults can be changed. Oh. Multiple values might not get merged properly. Inspection of it's almost impossible because it's an opaque string and more. The first part of this RFC aims to discourage such options and encourage people to use the settings pattern instead, which can encode the module's configuration file as a structural Nix value. Here is an example showcasing some advantages. Old way. Let's see the old way. Old way. Services foo extra config. So this is interesting. Old way. Services foo extra config can be set in multiple files because string concatenation doesn't merge such lists. Yeah, like you have no functionality. Listen ports, blah, blah, can override this settings because the module hard codes it. You cannot override this. Yeah, you have to write it all again. Because if you put all these things in settings, then you can change them. Enable IPv6. Check interval. Services foo settings. Listen ports, bootstrap, IPS. So like this, you can change the data, right? It's much better. Jump to the detailed design, how the module implementing the settings approach might look like. Balancing module option count. Yeah, this is something to study also. This is a lot. This is a lot. Wait, I have to, where am I going to put this? My file is going to turn into a big mess. Paste this preview. Yeah, this is important also. You can learn a lot. You can learn a lot, and also how to contribute. So this is something that I have to study, portable service layer. Yeah. But look, there's so much. Oh, wow. It's a lot. How long have I been recording this? 56 minutes. I think it's enough for now. Yeah, maybe I went a bit too deep with the find common number, but it's kind of, it's always, I think it's good to refresh this. No, it was good for me to refresh this. How does it look in Nix? Portable service layer. All right. So that's, I guess, the first part of 762 parts of the NixOS module deep dive. All right, thanks.